Hello and welcome. One use of layers in Unity is to define which game objects are rendered by a particular camera. The culling mask property of a camera includes or omits layers of objects to be rendered by the camera. Let's create three layers: red layer, blue layer, and others layer. Then we assign the red cubes to the red layer, the blue cubes to the blue layer, but the floor and the sphere to the others layer. Now we'll create two cameras in our scene, setting the culling mask of camera red to include only red layer will display only the red cubes. Then also setting the culling mask of camera blue to include only blue layer will render only blue cubes. You can see that each camera displays only layers assigned to the culling mask. To display the floor and the sphere, let's add others layer to the culling mask of the two cameras. A camera in Unity has two modes of projection: perspective and orthographic. With perspective projection, the camera displays objects the way the human eye does, giving it a 3D appearance. Further objects appear smaller and closer to each other. But when the camera is set to orthographic, all objects in view appear to be of the same distance from the camera. The field of view is the camera's view angle. Watch how the gizmo lines in the scene view show the field of view as we change its value on the camera. Also notice the effect in the game view. By default, a camera has a near clipping plane of 0.3 and a far clipping plane of 1000. This means that any game object closer than 0.3 units from the camera or more than 1000 units farther away from the camera will not be rendered by the camera. The near and far clipping planes of a camera form the camera view's frustum. Multiple cameras in a scene are drawn in an order specified by their depth property. The default camera depth value is -1. Cameras with a larger depth value will be drawn on top of cameras with a smaller value. Viewport rect specify a rectangular area on the screen where the camera will be drawn. Here in our scene, we have a first-person camera attached to our player object. Let's create a second camera and position it to render from the top. We'll then set its viewport rect to display at the top left corner of the screen. We also need to give this second camera a larger depth value so that it renders after the first person camera has rendered. Render textures are textures that can be rendered to. This allows a camera to render on a game object, turning it into a monitor or display. In our scene, the player needs to move from the left side of the wall to the right. Enemies are patrolling the other side and might see him through the glass wall. The player needs to pass at a time that the enemies are hidden. The render texture can be used to make a surveillance camera for the player. Let's create one. We first create our camera and position it on top of the enemies. Then we create a monitor that the surveillance camera will render onto. We then create a render texture material and assign it to the monitor. Finally, we assign the render texture to the surveillance camera's render texture property. And now in real time, the render texture is making the surveillance camera render onto the display. Please subscribe to this channel for more videos. Thank you.